Hey there, year 11s. This is a population growth example now. And really, in this example here, I'd say the confusing part is not so much the technique, but more so the interpretation. So here it says there are approximately 10 times as many red kangaroos as gray kangaroos. How I interpret that line is that there are 10 times as many reds, meaning that if there was one red, okay, there are 10 times as many of these as there are for the gray kangaroos. So that tells me that one red is equal to 10 of these grays. Okay, so I'd probably say that was the hardest part to interpret. 10 times as many red kangaroos. So whatever the number of red kangaroos are, there are 10 times as many for gray. Does that make sense? Okay, so that's why I know, and it feels like you're doing 10 times the red, doesn't it? But it's not, because it's saying that whatever red is, there's going to be 10 times as many of that for the grays. Okay, so 10 times many of those grays will be equivalent to one of these reds. Okay, so think of it as 10 times the grays will equal to the reds. Okay, that's why you would say 10 times as many of these reds, so as many reds as gray kangaroos. Okay, that's a very confusing line to start off with, but that's essentially what they're trying to say. Then the next parts are pretty straightforward. If the population of the gray kangaroos increases at a rate of 11% per annum, now increasing, that tells me that gray, if we were to model it, it starts off with G0, so there's X amount of kangaroos to start off with, and it increases by 11%. So we know that 1 is itself, it's not doubling, it's only by 11%, so it's 0.11 is telling me it's increasing by 11%. If it's decreasing by 11%, you would have taken 1, take away 11, would have been 0.89%. Okay, so this is all to do with percentages back in year 8 and 9. So it's increasing by 11%, so it's 1.11. That's the rate of growth. So that means over time, let's say I call n for the number of years. That's the model, exponential model for my grays. Okay. Then for my reds, they say that it decreases at 5% per annum. So that tells me already I'm dropping by 5%. So it's 1 take away 5%, which is 0.95 to the power of n, red naught, and red. Okay. But keep in mind, remember that red, when you first started, red was equivalent to 10 grays. Okay, so another way of writing this is, it is the same. So I'm going to write here equation 1, equation 2. This is the same thing as saying 10 times whatever the original grays were, 0.95 to the power of n. So that is the relationship. Okay, so hopefully having that on the side, that will help us solve it later. Okay, so those are our two key parts there. Then, what do they say? Find how many years must elapse before the proportions are reversed. Okay, so we want the proportions to reverse. Now, the current proportion, so I write here current proportion, is for one red, that's equivalent to 10 times the grays, right? Then, if the proportions were reversed proportion, that means we want now that it will be like this. Okay, so this is what we're trying to find. Using our model, we know that the gray kangaroos will increase by 11% over time. So I will then write the model. I say, okay, well, according to the model, this is how long it will be. G0 times 1.11 to the power of n. That's for my grays. But then 10 times my reds, well, the reds started off with, again, this is my formula for the reds. So I would then say it's 10 times G0 of 0.95 to the power of n. Okay, so that is my model. And the reason why we had changed to the G0 initially is so that we can now solve. See, it's all in terms of G naught. And the convenience here is that if I divide by G naught on both sides, these cancel out. So then in your next line here, this is nice because you get 1.11 to the power of n is equal to 100 times 0.95 to the power of n. Okay? And that gives us essentially a model to work with now. So what are we trying to find? We're trying to find how many years, when I say equals, okay, when I say equals, that means that this is when the proportions have been reversed. It's that the grays will be equivalent to 10 times the red. That's what we're working with right now. Okay, that's what we're calculating. So from here, I'd probably, if we would do it by hand, it's a pretty messy one. I'll probably do it with a CAS. But if you really wanted to do this by hand, how do you isolate the ends? Well, this is how you would do it. You'd say, since they both have a different base, 1.11 and 0.95, you can take a normal log of both sides, just so you can use rule number 3 to move it away. So I can do log base 10 on the left, log base 10 on the right. Okay? And if I do that, this is what it's going to look like. Log base 10 of 1.11 to the power of n is equal to log base 10 of 100 times 0.95 to the power of n. Okay? And conveniently here we would probably need to separate these two terms because it's timesing. We can separate those two terms. I'm probably going to need more space. I'm going to press enter. Here we go. So over here is fine. We can use rule number 3 and bring the n down. So this now becomes n times log base 10 of 1.11 is equal to, and over here if we split up the log, it's log 10 of 100 plus log 10 of 0.95 to the power of n. Okay, so I'm kind of moving to the other side, aren't I? I'm probably going to see if I can make it a bit smaller. Actually, I'll do it this one. Maybe I should just move it across, and then I'll make it smaller. There we go. Yeah, I'll do that. Okay, so moving on from here, we can say that we know this is equal to, so this is doing by hand, by the way. So 10 to the power of what gives 100, that's 2. This one, we can now drop the power n down. So that now becomes, in our next line, it's n times log base 10 of 1.11 is equal to 2 plus n times log base 10 of 0.95. Okay, and the reason why you do that is now you can collect the n. So move this entire term across. How do you do that? Minus both sides. Minus n times, this is very algebra heavy for those who are really struggling with inverse operations and solving. I know that this is going to be very confusing to you right now. Okay, so hence why you could probably use a calculator at this point. But if you're okay, this is pretty good. That means you know how to work with your algebra. So n times log base 10 of 1.11 minus n times log base 10 of 0.95 is equal to 2. Okay, and you can see here that they both have a common factor of n. So you can take out n as a common factor. So n as a common factor, and you get log 10 of 1.11 minus log 10 of 0.95 is equal to 2, and yeah, you can probably just divide them now. So n is equal to 2 over that massive idea log 10 of 1.11, take away log 10 of 0.95. And technically, you can bring them both together, so these two, and combine it as one log if you want. But I'd say just keep it there and then type it on your calculator. Okay, so from here, this was a real mess that we finally got up to, and then using your CAS now, I'm going to use our CAS. Let's do this. So using our CAS, we're finding 2 over the the log base 10 of 1.11 minus the log base 10 of 0.95. And that gives me 29.586. All right, cool. So to answer the question, how many years does it take? Well, that was a nasty one. Here we go. Zoom in, and that just means that it takes approximately 29.5 years, or you can say 30 years. Okay, so approximately 29.5 years or 30 years. I'm going to make that a bit smaller. There you go. So that's how long it takes before the proportions are reversed. So what was hard about this example? I'd say that maybe the starting interpretation of 10 times as many red kangaroos as grey kangaroos, and then the algebra if you wanted to do it by hand from here. I mean, you could have done it on a CAS from that point, and it probably would have got the answer as well. Okay? All right, that's how you